By the way, out of curiosity, have any of you guys dared to denture? You do wear dentures now. Have you ventured back into the CISL or the Mass Science Center for tutoring help? Yes? Yeah? Which one then? MSc or the CISL? MSc? Okay. Okay. Don't forget. You got my office hours. If you think I suck and I don't explain anything well, you've got peer tutors who are students who tutor because they've taken a lot of math and they've done pretty well. And then you've got instructors who work in the CISL. You have access to all of those. It's kind of insane. So if you have time between classes, I would go do my work, and just knowing there's people around you that can help sometimes makes it easier to do the work. It alleviates some of that anxiety that you might feel when you're like feeling like you're dangling off somewhere by yourself. Yes? Okay. Can't stress this enough. Let's see, number 80 in which section you said? 3-1?
Yeah.
Oh my God, it's sick. Okay. Oh, good. Okay. I always forget that I put some of these graphing problems on here. We haven't done like a graphing calculator day yet. Let me think about how I want to do this. All right, let me do two things. I want to remind you that in the Canvas shell, dadgummit. Oh wait, will that work? Yes. No. Oh God, I just love it so much. Okay. All right, screw this. In the Canvas shell, there is a TI calculator guide. As I say that, I'm really certain I put it up there. 100%. And it explains how to do certain things. Let me show you how to do this one. Maybe I can I'll bring my calculator, I'll bring copies of the calculator guide tomorrow, my bag of calculators. I'm going to show you how to specifically do this. Oh, let me make sure what was it. It was 1 over x squared. No, x cubed. Think about my other class. Okay. And it wants you to do it on the given domain. So watch this. If you have your calculator, we do this again. The whole top row, all the buttons on the top of your calculator are all about graphing. The reason this calculator is rather expensive compared to other ones is because of its graphing capability. So everything on the top row is all about graphing. So if I hit y equals, that's how I tell the calculator what function to work with. So if I hit y equals, I can tell it, I want you to work with x. Does anyone know where what I call the to the button? X to the third power. Do you know where your to the button is? Your power button. Does anyone know which one that is? Yes?
Underneath and clear.
Yeah, it's called the caret. Yes? So X, I call this the to the button. X to the third power. Now, if you have your own calculator right now, and you're doing this with me, does anyone not have the 3 showing up like a little exponent? Is everybody who has their calculator with me? Okay. Does everybody who has their calculator, have you put this in, does it look like this? Okay, I'm going to take that as a yes. Okay. Because some of the older calculators would have like a little caret symbol and then a 3. The newer ones actually make it look like a power. Okay. The thing you have to remember, if there was more stuff you wanted to type in, you would have to hit the over arrow to come back down. Do you see how I'm in the exponent right now? Anything I type now would be up in the exponent. If I wanted this to be x cubed plus 2x, I'd have to hit the over button. Over. Now I'm back down, and then I could type in plus 2x or whatever. Okay. If I just hit graph right now, I know this is not going to be right because I was using this morning. Look at that. What do you guys think when you see that? This is the graph of the function. It is. It's just what part of the function am I looking at? That's the question, right? My window is set weird. Let me stop for a minute. You guys semi with me? And again, I haven't said this yet this semester, but if we had enough computer labs, if community colleges were funded well, and we are not, we would have more computer labs, and I would be able to let you guys use something called Desmos. Real quick, since I said that, how many of you guys know about Desmos? Anybody? How many guys feel like you've never heard of Desmos and you're worried that it's some kind of a death cult? Okay. It's not a death cult. At least not the one I belong to. I can give you information about mine. Desmos, just to kind of show you, if you're at home, Desmois? No, Jeff. Desmos kicks so much ass. Because if you type in y equals x to the third power, you could very easily just scroll and move around. Yes? Do you see what I'm saying? Maybe? Sort of? Screw you, Jeff? And if you put in other stuff, let me make it more interesting. There we go. If you click it, it'll even do stuff like tell you the lowest point and the highest point. Do you see that? It's a little small, but you guys see it. So Desmos kicks so much ass. It's much less clunky than the TI, but the TI's main selling point is you can take it with you. We're not in a computer lab. We don't have enough of them, so we're going to use TI. So let me go back to the TI. If I hit Zoom 6, so Zoom, I can zoom in, I can zoom out, I can do all this other stuff. Zoombox is neat. It's kind of like CSIS and CSI Enhanced. You know, you ever watch those crime scenes and they're like, enhance, enhance. So Zoombox, you can just draw a box around a part and make it zoom in on that part. So if I just hit Zoom Standard, that's going to take it back from negative 10 to 10, negative 10 to 10. So what that means is negative 10 to 10, negative 10 to 10. How are we all doing? Are we all good? Okay. This is the most fundamental graphing capability this thing has. It can do so much graphing shit, which is why it costs 100 whatever bucks. Okay. Maybe 90 on a good day. Coming back to the question, because I forgot. The question says, no, Jeff, that's Desmos. Graph this on the given domain. So can somebody tell me, this is on the given domain. What the shit does this mean then? For example, what does this mean?
Minimum and maximum.
Minimum x values, right? Domain, yes, domain. So I want the minimum x to be negative 10 and the maximum x to be 10. You guys with me? Isn't that what I currently have on the screen, on my calculator? As I did Zoom Standard, then it goes from negative 10 to 10. Why is this not good? What's the last output I can see? What's the first input that has an output that I can see on my screen? It's like around here. Yes? Do you see how that's not ideal? I want to be able to see where all this shit goes. So what's the problem? Why can't I see all that? Do it again. I'm zoomed in. I'm not seeing far up enough and down enough, yes? What's the function again? X cubed. Where's the output then for negative 10? What do you get when you plug a negative 10 into y equals x cubed? What's negative 10 cubed? What's 10 times 10 times 10? So it's negative 1,000. Are you guys with me? So how far do I want to be able to see? Down. Negative 1,000. 10 would be how far up do I want to see? Positive 1,000. How do I change that? So this is my current window. Okay, this is funny because you guys have met me. We've been together for 2 weeks, right? You're like, really? It feels like years. I look at this in a very strange way. We're in a submarine, and there's these monsters. There's these function monsters. So we're looking at an x cubed function monster right now. I'm looking at my little porthole in my submarine, and I can see just this much of the function monster. How much more is there? Infinite amounts, yes? Yeah. And I currently would like to see where this goes and where that goes. I just need to, like, my submarine is magic, by the way. I can make the window go up and down further. I can make it go left and right further. Yes? So what button relates to what I just was talking about?
Probably the window.
The window button. If I hit the window button, my domain, is my domain cool? Negative 10 to 10 for my x's. What we just said we wanted the y's to go from to. Negative 1,000 to 1,000, yes? So I'm going to make y min become what? Negative 1,000. And y max? 1,000. Let's see what we get now. Hey, look. The whole screen is filled up. I can see the monster better. Looks a little not Loch Ness Monsterish. Yes? Okay. Maybe. So in that problem, it was partially graphing calculator, but also, how do you tell what to set the range to? Well, it depends on what the outputs would be. You look at your domain and you figure out what's the biggest and smallest output. That's what tells me what to make y min and y max. And I'm literally, I can turn my submarine, I can make my window bigger or smaller, I can move it this way, that way, right? So that's what the window button does. I can directly control how much of the outside world I'm looking at. Okay, maybe. Potentially. Okay. All right. Just gotta be careful because some of you guys have no idea what's going on in your life. And some of you guys are like, So we'll do more graphing calculator stuff. I'll devote some time tomorrow. I'll bring copies of that TI calculator guide. And it basically highlights everything we're going to do this semester with the TI graphing calculator. Okay. I always forget there's a few problems in these early sections related to graphing calculator usage. Anything else from homework stuff? Yes?
Where do we find said homework? Is it in the textbook that we get at the bookstore? Or is it somewhere else?
If you wanted to, does the bookstore have this textbook? That's a good question.
I don't know.
No, because you can get it cheap, or you can not even pay for it.
Okay.
I'm looking at the textbook right now. I'm looking at the homework right now.
Okay.
Yeah. So there's a link in Canvas to the textbook. There's a PDF of the textbook, and right above it, there's a link to the textbook in the modules.
Okay.
You just have to pull the textbook up. You can order a hard copy if you want to. It's like 40 something bucks for a hard copy, black and white. But it's massive. Does anyone have that book? Yes. Yes. You could. It's like Thor's hammer. You can put it on somebody, and they'll be like. So we'll see if you're worthy. If you get it, it comes to you, and you can't pick the box up, then you're not worthy. I'm sorry. Or you can just access it online. I got the PDF up there. It's either way. Yes. Is that cool? I totally love the people that need the physical copy so they can highlight and do shit. Beautiful. Tears. I try to make it cheaper than stupid freaking. I'm sure you bought almost $200 books before. Yes? Okay. Is everybody cool with that? All right. Is any homework late yet?
No.
When is the first time the homework is late? After the day of the test. Yes. Okay. Where should you be in the homework? I don't know. I'd say right now you should definitely have, if you're not in 3-2, you're a little behind. Yes? Okay. So, let's do this. Any other questions from homework? It was a beautiful example of a problem. You're like, I don't even know, we didn't talk about this shit. We're gonna just bring it up. Anything else before we go on? Yes, go for it. Section which one? 3-2? Number 55? Okay. Hi-ya. Oh, okay. Yeah, that's the other one. So again, these are two separate problems. This one, they want x min to be this and x max to be this. So you're looking at a very narrow range on the x-axis. How do you determine what the range should be? Help me out. What's the function we're analyzing in this problem? What function are we analyzing? Y equals 1 over x squared, yes? Does everybody see that these are two different problems? So let's just talk about that problem. If I make my domain this, my x min, my x max, how do I figure out what to make my range so it all fits on the screen? Plug in negative 0.5, plug in negative 0.1, and that'll tell you what the y min, y max is. Yes? Make sure you make y min the smaller option, not necessarily what you get in the order of what you plug in. Give it a try, let me know if you have issues still. And then you do the second problem, same way, just the second problem. Yeah. They weren't very clear on the fact that those are two separate domains. Okay. If anybody's still having trouble getting a graphing calculator, just to remind you guys, has anybody gone to the library to actually check one out? I'm pretty sure you can check one out for like, alright, I don't want to say this. I think it's for the whole semester you can check one out for.
Yeah.
It's silly. So if you get there soon, there might be some left. And you can check one out for the whole semester and save like a lot of money. Now most of you guys are going to take calculus, so you're going to have to do it again. Then you get in there even earlier to make sure you can get a graphing.
From UPS.
Oh, cool. Yeah, certain programs you could be a part of on campus might get you access to calculators. Hell yeah. But if you have a lot of trouble, if you're like, nothing's working, Jeff, then just come see me. I'll figure it out. Okay. All right. Love it. Anything else from homework stuff? And never feel bad. I saw your face. If you're the only one asking, you got like 5 questions, go for it. Right? Everybody else is seating. Everybody in here has equal rights on the floor when I'm asking the last questions. If nobody's talking, then the floor is completely yours. Do you understand? Never apologize for having questions. You should only apologize if you don't have any. Okay. I know you have them. What kills me is why you didn't ask them. It always kills me a little bit, but it's okay. Maybe I'm intimidating. All right. So let's do this. Let's go in order. That would be neat. Let's talk about section 3.3. Then I'll show you how we've already done section 3.4, which is neat. We're going to open up our lecture books, the purple book. Does anyone need a copy? We're going to open up to module 4. Does anyone need a copy of module 4? There we go. I have many copies. Well, 8. I need one for myself because I still haven't gotten a book for myself yet. Good. Anybody else? Everybody else is good? Sweet. Oh.
Thank you.
I'm going to talk about this, and then I'm going to talk about, I'm going to do it like this. Yeah. This, and then we'll talk about composition of functions, inverses, and then I have a worksheet. Okay, so we're all gonna endure Jeff just freaking talking. We're gonna make it. There's a lot of words here. But let me ask you this. I really apologize for this, but I told you already, I'm teaching like 2 pre-calc courses basically. So I always feel like I've talked about something and then no I haven't. Can you guys help me out? If you take a trip and you're going to Sacramento, right? Has anybody ever driven up the coast? Has anybody ever driven to like Seattle up the coast? No? You should. If you have never done the Oregon coast, do it. And let's say you drive up the coast and you sometimes you make a stop. You make a stop because you need some snacks, you need some lunch, you go to the bathroom, whatever. All right? Isn't there like an average speed you're going? Yeah. That doesn't mean you're always going that speed, of course, right? It's just like there's an average class grade on the quiz. It doesn't mean everybody made that grade. How do I determine the average speed? What would I need to know? Do it again. Yes? Divided by? Time. Because what's units on speed? How fast were you going when you came to school today? I'm not going to turn you on. Miles per hour. You're a smart man. He's like, I'm not going to give you the number, man. I don't know what number. You have to tell me if you're a cop. Also, all right. You guys kind of with me? So I was going like 70 miles an hour when I came. Right? Going to LA, you're like, holy shit. Miles per hour. So speed is distance divided by time. Yes? You guys remember the DIRT equation? DIRT equation is D equals RT. Distance equals rate times time. DIRT. That's D equals RT. D-E-R-T, DIRT. Spelled correctly. So, if I start at home, and this is my distance from home, and this is how long it's taken me. And let's say after 1 hour, I've gone 40 miles. After 2 hours, I've gone 50 miles. So obviously I either hit traffic, right, this is California. And then after 3 hours, I've gone 70 miles. My scale sucks, but we're all gonna survive. Is everybody with me? I didn't travel at the same speed, but isn't there an average speed that I went? How would I get that average speed? Yeah, how far did I go? 70 miles. Over how much time? 3 hours. So, this is a very simplified version of what I'm saying. And let me say speed a different way. What is speed? What does it measure? What does speed measure? Say again? You know the magic word, Helen. So speed measures the change in distance over the change in time. It measures the average rate of change of distance. Did you see that? Is that cool? It's an average rate of change. Now when we get to lines, we're going to call that shit a slope. But I like doing this by itself because you guys have to understand slope exists. Lines are one thing that utilize slope, but slope exists. In fact, one thing you study the hell out of when you get to calculus is you study how to get slopes for things that aren't straight. How to get a slope for a curvy thing. Yes? The Loch Ness Monster function. How do you get its slope? Okay. Before Nietzsche, wrap up. So I want you to really focus. Do these points matter?
Yes.
Do they?
Yeah. Oh.
What are the only 2 points that matter? The first and the last, yes? In the middle, I could have been doing all kinds of weird shit. I could have left later and then just really went fast. Yes? Or I could have really went fast, noticed how I had some cops by me and then slowed down. Yes? I mean, do you guys see what I'm saying? The average velocity, the average speed, wouldn't change. All that matters is the endpoints. Because the endpoints tell me how much total time it took me to go how much distance, yes? So I would take the output for an input of 3. Let me say this is a function of time. I'm going to write this really weird for a second. If f of t is my distance, what's f of 3 mean?
Y at x equals
No, what's it mean? Not how to get it. What's it mean? F is my distance formula, yes? What's t? Time. So what's f of 3 mean? At 3 hours, this will tell me the distance I've gone, yes? Now, at 3 hours, how far had I gone? 70 miles. Do you see what I'm prepping you for? I'm prepping you for the case where they don't give you a graph, they don't give you the numbers, they just give you a function. So if I know at 3 hours how far I've gone, minus how far I've gone at the beginning, stay with me now. And how long was I going? 3 minus 0. What is f of 3 in general? What's 3? It's the what? It's the number that you're putting in. So what is it? The 3 would be the input. What's f of 3? Yeah, 3 would be like our x, in this case our t, but what would f of 3 be? The thing that you get out. It would be the output, yes? It would be the y variable, right? In general. So isn't this just, how many outputs do I have? 2. How many inputs do I have? 2. So isn't this like y2 minus y1 over x2 minus x1? Does that sound familiar to anybody? That's just the dumb slope, right? So again, slope for lines is a specific application of this idea of rate of change. A line is interesting because its rate of change never changes. Did our rate of change? How fast we were going, did it change? Yes, but I still have an average rate of change I could calculate for the whole trip. Okay. So if I want to actually do this, what's f of 3? At 3 hours, how far were we? 70. At the beginning, I was at home, so I was 0. And then I just do 70 divided by 3. Yes? Which is what? 23.3333333. 23 1/3 miles per hour. Which, you know, around 4 o'clock in California, that's about how fast you might hope you can go. Okay, maybe. Screw you, Jeff. So given, I don't have to be given, and by the way, I'm kind of bypassing, we already talked about the increasing, decreasing stuff, yes? If I remember correctly, yes. So what I really want to focus on is, oh, we did do some of this. I remember this. Did we do some of this? Yeah. We talked about this. Okay. Well, it's probably good that we're talking about it again, because all of you look at me like this is brand new. There's my average rate of change formula. So if I give you a function, we could just get the average rate of change. I think we did this problem. Yeah, okay. And then I think I did, let's do this. Look at example 8. So they give us a function. They don't give us a graph. They don't give us points. They give us a function, Dan. Find the average velocity over the time interval 4 to 8. So in this case, what is 4 to 8? What does that represent? Of what? No. Time. It's the time interval, right? And that's our inputs. So what do we have to put on the top? So in this case, what does my average rate of change formula want for me? I have to figure out what. So on the bottom, I've got my inputs. The second one minus the first one. On the top, I need my outputs, yes? I need the output where? What do I need the output for? What input? What are my inputs? 4 and 8. Yes? 4 and 8. They're my inputs. You with me? Because again, remember, whatever does in the middle really doesn't matter. All that matters is how far does it get overall. I don't care if it's doing all this weird wavy shit in the middle. I just care about where to start, where to end. My inputs are 4 and 8. Yes? So what are my outputs? How do I figure out my outputs? You plug, that's crazy. So if you plug in 8 and you plug in 4, I can take the difference to see how much it changed. That's why average rate of change has a bunch of minuses in it, because that's how you figure out how much something's changed, is you take a difference. How do you figure out what S of 8 is? What formula? Yeah, they won't give it to you. They told me what the function is. So let's do 8 on the side here. So the 1/2 of what? Oh, okay. Yeah, 1/2 of 8 squared, yes? What am I plugging in? I'm plugging an 8 in. So the 1/2, 8 squared minus, keep going, 6 times 8 plus 23. This is 64. What's half of 64? 32. What's 6 times 8? 48. And if I do 23 plus 32, that's 32 plus 23? 55. What's 55 minus 48? 7. Okay. What else do I need? So what did we just figure out? What is 7? What did we just figure out? What did we just figure out? Yeah, we figured out S of 8. Yes? Y2 minus Y1 over X2 minus X1. What else do I need? I need S of 4. So I do all this business again. What would S of 4 be? It'd be 1/2 4 squared minus 6 times 4 plus 23. 4 squared is 16. Half of 16 is 8. 6 times 4 is 24. 8 and 23 is 31 minus 24 is 7. Weird. I don't know if you guys see why that's weird. They're both 7. It's like this. It's like, how do I say this? Here's the weird thing about velocity. Let me see if you guys are cool with this. So if I start at this point, you guys see me? I'm right here, yes? If I go over here, and then I go, okay. That took me like 5 seconds, maybe 4 seconds, whatever. How far did I go? Looking at where I ended up, did I get anywhere? No. It's really if I leave my house to go on a big trip, and then 2 hours later I'm like, I forgot. So I gotta go back. I got nowhere. Yes. My average speed would be 0 because I've actually gone no distance away from the house. You guys with me? My average velocity, be very careful. Velocity includes direction. So like if I come back, it kind of takes away from itself. Okay, so in this case, the particle starts at 7 feet. It moves around and then it comes back to 7 feet. So how far did it go? Nowhere. So in this case, 7 minus 7 over 4, 0. So velocity cares if you come back to where you started. If you go back on yourself, velocity will be less. Speed is different. Speed doesn't give a shit where you end up. All it cares about is how fast were you going as you walked around. So I was going at a certain speed. Maybe you guys are with me. I don't know. This might not. This place is a little weird. Let's look at this problem. It might be a little more interesting. So we got a company making TVs, and the revenue is modeled by this, where X is measured in hundreds of televisions, and R is measured in thousands of dollars. So, blah, 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 blah. Okay. So what does this really mean? X equals 2. What does that mean physically?
You next coming.
Of?
Television.
So what does X equal 2 mean?
200 television.
200 televisions sold. You guys with me?
Yes.
So you're going to make some money for that, right? Now, real quick, I'm not going to make this a business class. What's the difference between revenue and profit? Any?
Revenue is what you make.
Revenue is purely just how much money you're taking in. Now, if you bring in $500, but it costs $1,000 just to make that money, then your profit would be negative $500. Okay, I don't know why I'm bringing this up. So this is just revenue, yes? Do you see how it's the same problem as example 8, though, in terms of the form of what you have to do? What am I going to put on the bottom? In fact, let's do this. What are my 2 points? 2 something, 4 something, yes? 2 and 4 are my inputs, yes? How do I figure out my outputs? Yeah, what's R of 2 and what's R of 4? Let's see, it'll be negative. I'm going to write this as a half. Is that cool?
Yeah.
2 squared plus 12 times 2 minus 4. This will be negative a half times 4 squared plus 12 times 4 minus 4. So really, I need you to notice something. All we're really doing is for given x's, we're figuring out the y's, and then we're finding the slope. That's really what average rate of change is. It's the difference in the outputs, so the difference in the y's, divided by the difference in the inputs, the x's. So this will be half of 4 is 2, negative 2 plus 24 is 22 minus 4 is 18, is that right? You never know with me. Yes. And then 4 squared is 16, half of that is 8, so negative 8 plus 48 is 40 minus 4 is 36. So now I know my points. So again, just in form, my inputs are 4 and 2. On the top is going to be R of 4 minus R of 2. So if I know how much my outputs are, I can see how much those changed over how much my inputs changed. What would the units be on this answer before we even get it? What's revenue in? Thousands of dollars. And what's the inputs in? Hundreds of TVs. So the units of this would be thousands of dollars per 100 TVs. How much revenue, how many thousands of dollars of revenue I made per 100 TVs? So R of 4 we figured out. 36. R of 2 we figured out. 18. And then my 2 inputs are 4 and 2. So I get, what's 36 minus 18? 36 minus 18? 18. Divided by 2, I'm going to catch up to you, 9. So my revenue was $9,000 per 100 TVs, or $90 per TV. You guys with me? $9,000 for 100 TVs is $90 per TV. That's how much revenue I made for each TV. If it costs $98 per TV, I'm losing money. Do you see that? All right, I'm not going to make this a business class. That's the other half of the story here. That's important. Okay. Maybe. So it literally, you could look at it one of two ways. You've got this formula that you could use. Where'd it go? My poor little formula. Oh. Should be right there. Where'd you go? Oh my goodness gracious. Here we go. We got this formula here. Yes? We've used it several times. We did the S of t, blah, blah, blah. We did the R of x, blah, blah, blah. Or you could look at it purely as get the 2 points and then get the slope. y2 minus y1 divided by x2 minus x1. Which is something I know you've all done before. So another name for slope is average rate of change. All right, so that's one idea by itself. We've already talked about increasing and decreasing stuff. So that's what else is in this section. Yeah, I'm not going to do that. Like for example, just to kind of remember this. Did we do these? I don't think so. These are not as interesting. Like this one here, this W. This W here. What's the domain for this? Who remembers? This will be a little review. What's the domain? In general, what's the domain?
Negative infinity.
Well, why is it that in this case? What is the domain in general? All the what's? X values. All the inputs that have outputs. Cool. And what's the range? All the outputs. So domain in this case, because those arrows are there, it goes up and down forever. So domain would be all reals. Or you could say negative infinity to infinity. Or all real numbers. What's the range? Is there a lowest or a highest output? Yeah. The outputs I get, do I ever get an output in -6? No, the lowest the outputs go is -5. Do I include -5? So what symbol do I put on -5? The bracket. And how far up does it go? Nice. And you never include infinity. Don't ever put a bracket on infinity, because then I'll ask you to bring infinity into the next class. Yes.
Why is it infinity?
Which part?
Like for the range. Why would it be?
Oh, is there a highest point where it stops?
Oh no.
So how high up does it go?
It just keeps going forever.
Yeah, if you ever say forever, that's infinity.
And so then why not positive? Why would it be positive?
Oh, that would be a local max. Because see, that's a local max. But does it win the whole contest overall? No, it gets higher than that. So if I said, what's the next two, the word relative is also another word for local. So I normally use the word local. Relative really just means local. We use the word relative because it means relative to the immediate surroundings. The local max, we just said. What's the local maximum value? 1. Where does it happen? At x equal -1. Good. Where is x? What is y? I don't know third base. What's the local? Is there a local min? Yeah, it happens how many times? Twice. So there's a local max of 1 at x equal -1. There's a local min of 5 at what? I'm sorry, -5 at x equal to. So when's it hit -5? What input makes it -5? 2 and -4. Good. So these are winners of the local competitions, right? These two are actually the actual minimum. But did this guy win nationals?
No.
Nope, other people went higher. Yes? Okay. So you have local competitions, that's local max and min, and then you got the real max and min, what we call the absolute max and min, but you'll talk about that in calculus. Increasing, decreasing, we did a lot of problems, didn't we? Where is this thing increasing? Yeah, it starts to increase at -4. Is that cool? Never give me y values because I'm asking where. Where is it increasing? From -4 up to what? When's it end? When's it stop increasing? What x value? -1. Where else is it increasing? 2 starts increasing at 2. Yes. Up to what x value? Does it ever stop increasing after 2? Decreasing is the same way. Okay. So we've done that before. I don't want to spend too much time on that, but that's a nice little review. Oh. Okay. Blah 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 blah. Nope. Blah blah. We did that. We actually did those. Oh, you're good. You're good. I like it. We did more than I thought. This is good. So now, there is one idea that we've already discussed that I need you to realize is, here, let me give you this. Oh, who is it that needed copies? Because we're going to look at module 5. Anybody else need any copies? Who was it? Oh, shit. Who else needs it? Anybody over there needs it? Okay, I'll be over there in a second. Hold on, guys. You want to keep it in order for yourself? Sorry. Module 5. Yeah. Oh. There. There. Okay. So now I have to do this. The composition of functions, I really don't want to or need to spend a ton of time on. The one thing I do have to point out, and I can't remember if our book does this. All right, do you guys see this? And you're like, yes, Jeff. Of course, this is sometimes how students feel when they're learning math, that they're in a fog. You ready for this? I hate this notation. This notation is so dumb. What that notation means, this literally means f of g of x. That's that little o is like of. Like Peter O'Malley. That actually means of whatever the area. So, where am I at? Glasses. The better way to write this is f of g of x. What am I shoving into f? G of x. We've already discussed this. And this is nothing different from just what function notation is. Whatever's in it, you put it in it. So what is g of x? What is g of x? Yeah, 2x squared minus 5. So I'm going to take that and I'm going to put it into f. How do I do that? What is f? 4 times stuff plus 3. 4 times what plus 3?
2x squared.
Yes, I'm just plugging that in. So this just says whatever this is, put it there. Whatever this is, Put it there. That's all it means. Now what can I do? I can do a little bit with this. What can I do with this? I can circle it. Go home, Jeff. No. What can I do with this? Distribute. 4 times 2x squared is 8x squared. 4 times negative 5 is negative 20 plus 3. So what's negative 20 plus 3? Negative 17. So simplify after you plug stuff in. Yes? Now let me show you this. We have a function now. We have a function that is, so this is asking what is f of g of negative 2, but you see how I can do this? I can just plug this shit in there. What function is this? It's the f of g function, yes? So if somebody says, hey, what's f of g of negative 2? I could just take that shit and I can just plug it in. I've already done part of the work mathematically. I've already made an f of g function. So if somebody says, hey man, what's f of g negative 2? I can just plug that damn thing into what I know f of g is.
Yes, sir. So where does the positive 3 come from again? On the left side of it?
Oh, look at the f function. What's the f function?
Oh, okay. Sorry.
You're good, you're good. It's in the f function, right? So it's 4 times stuff plus 3.
Yeah.
Yeah.
So you just have to figure out what's in the parentheses before adding the plus 3.
Yeah, this is just literally, it's just like whatever's in the x, you multiply by 4 and add 3 to it. So whatever's inside here, you multiply by 4 and add 3 to it.
Okay.
Because that's the rule for the function. You gotta love function notation. It just is substitution. It made it.
I got it.
And I know you know how to substitute. You know how to take a variable and put a number in the place of it. That's all functions are. Even if I'm putting variable shit in, I just put the variable shit in. I just put it in. And then I do whatever math I can. In this case, I could distribute. People, I don't blame you. You make a big deal out of this. Some people, unfortunately, look at this and say that says f times g, and they start dividing by f. Holy shit. That is f of g, not f times g, yes? Very different thing. Okay. It kind of leads to solving this equation here by dividing by the square root symbol. Does that make any sense? This is not square root times x. This is square root of x. Very different, yes? Okay. This is really the same problem. Let's see if there's anything interesting here. Look at this guy. Can anyone tell me what the domain of f is? We've looked at this kind of problem before. What's the domain of f? And remind me, what's domain mean? All the x values, all the inputs that have outputs.
Yeah.
Is there a number I could try to input that would not have an output? Negative 3. What would happen if I tried to do that?
0.
I would make a black hole. People would die. Be responsible with your math. What about g? So is everybody cool with that? F has a domain all real numbers except negative 3. What about g? All real numbers except 0. If I make x 0 is in the bottom 0, I'm trying to divide by 0, people die. Okay. What would this be? What does that say? What's a better way to write this? G of f of x. So what am I shoving where? This is where you can finally tell me to shove it. If you're specific. What am I shoving where? What function am I taking and putting into the other? Which one? I'm taking f and I'm shoving it into what? Into g, yes? What is f of x? 1 over x plus 3. Now here's where things get weird. Try to do the next step. Try to do it. Don't think too much. Just write down exactly, you know what to do. Don't overthink it. Your brain is going to balk. Your brain is going to say, I don't like that. Write it down anyway, and then we'll talk about what to do with it. Is anyone experiencing what I just said?
Yes.
Does your brain see what has to happen? And it's saying, what? Why are we doing this, man? How do I do functions? Where do I put this? Shove it in G, where exactly? Replace what with it? What do I replace with this? No. Into the X. I replace X with it. Yes? I know what you're about to say. You're saying it right, but you're not saying it like I need it in the moment. I'm going to replace X in G. I'm going to replace X with this. I'm going to put this there. All right, there's a person, I'm not going to point them out, I love it. The look on their face is this. I love it. Does anyone enjoy that? Can somebody describe to me what that says? Why is that gross? Why? Why is a poor little dude? He didn't want to exist. He didn't want to exist. Poor dude. He's over there going, here's my face. It's a fraction inside of a fraction, yeah? How do I divide fractions? Doesn't that say -2? Mm-hmm. Divided by fraction. How do I divide fractions? How do I divide fractions? -2 divided by 1 over x plus 3 is -2 times.
X plus 3 over.
Yeah, which is -2x minus 6. Now, real quick. To get the domain of this, don't look here. This domain is like all real numbers. Yes? There's no issues here. I can multiply anything I want to by -2, blah, 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 blah. Before we simplified, is there something x could not be? -3. Because it makes a 0 on the bottom, yes? So this guy's domain is all real numbers except -3. When I simplify it, I lost the idea that whatever this number is, it's underneath 1. Yes? Okay, maybe. I love you guys. Really quick, weird question. Do you see how -2 is divided by a number? 1 over x plus 3. Could 1 over x plus 3 ever be 0? How do you make a fraction 0? What is the only way to make a fraction 0? Give me a fraction that is 0. Okay. I love you guys. You're like, what the hell do you want from me? What do I... Let me see. Can you divide by 0? Can you divide by 0? No, that's off. That's out of here. Yes? What number would I divide by anything except 0 and still get 0? What number? Let me be specific. What number would I divide by 2 and get 0? 0. So 0 over 2 is 0, correct? Okay, this is really silly, right? But this is really weird. What's the only way a fraction can be 0? Is if the top is 0. This fraction, that fraction right there, this one, is the top ever 0? The top is always 1. So can it ever be 0? No. Beautiful. I don't know if you guys are with me. That's why the domain only throws out -3, because that's the only way a fraction can have a 0 on the bottom, because this fraction, this bottom can't be 0. Okay. They made this problem a little bit freakier than I think they wanted to, but still, it's a neat discussion. And you're all like, sure, we'll say it's neat, Jeff. Okay, maybe. Now, real quick, there is one problem. I want to get to a point where I can shut up. This problem is really nifty. I'm going to do it with you. Stay with me now. Now listen, for some reason, humans, I'll say this, especially boys, but everybody, we love to throw shit into lakes. And if that lake's frozen over a little bit, good enough. Now, most of you guys probably grew up around here. You've never seen a frozen lake, I don't know. But there's nothing more satisfying than throwing a rock and it just breaks through the ice and goes in, and then you can watch the ripples under the ice. I mean, come on. But even just tossing, even you can do the thing where you skip the stone, but just throwing it and then seeing the ripples come out, that's neat. So somebody throws a stone in a lake, and the lady of the lake gets hit in the head. She never gets a Excalibur. Throws a stone in the lake, and the ripples come out. That it says the ripples travel outward at 60 centimeters per second. Are you guys with? So after 1 second, how far is that ripple gone? After 2, it's gone 120. After T seconds, how far is it gone? Why'd you say 120 centimeters for 2 seconds? Because you did 60 times 2. What about 3 seconds? 60 times 3. What about T seconds? 60 times T. Good. All right. At the heart of it, all a function is a rule that says, if only I knew how many frickin' seconds, I would just multiply it by 60. Yes? That's what a function does. It just captures a rule. Man, if we only knew this is what we would do. In fact, that's freaking all of algebra right there. It's when we just throw variables into places and we're like, I really wish I knew what this number was because this is what I would do if I knew it. Now, does anyone know the area of a circle?
Something times pi.
Do it again?
Something times pi.
Yeah, there's a pi in there somewhere.
Yeah.
Yes? Which always makes me think about, I need to go get a piece of pie now. But does anyone remember? And I'm not sure I can control myself from showing you where this equation came from. And I'm sorry. Just keep talking forever. Pi r squared. Does anybody, you guys remember that? Does anyone know why that's the formula? Anybody? Would anyone like to know why that's the formula? All right, that's all I need is one yes. All right, just go with it. You're like, that's all we ever do, Jeff, is go with you. Just go with me for a second. You can't escape college without ever seeing where the shit pi r squared came from. Draw a circle. Pretend that's pretty good. For me, that's really good. Holy shit. My circles normally look like Stewie's head. You know Stewie from Family Guy. If I took this circle and I cut it in half, yes? That's pretty good. Look at that. I cut it in half. You with me? Okay. Before I do this, does anyone know the circumference of the circle? Given the radius here, does anyone know what the circumference is? Do it again. 2 pi r. Does that sound at all familiar to anybody?
Yes.
Just stay there. Just hold on. If I cut this in half, how far is this from here to here? How far is this? If all the way is 2 pi r, halfway is pi r. Okay, just remember that. You with me? From here to there is a length of pi r. Okay. This is so cool. If you've never seen this, this is neat. Someday I'll actually bring construction paper and do it that way, but too bad. If you cut down the middle, and then I want to cut from the middle out, but not through the edge, not through it. I don't want to cut through the edge. So I'm going to cut like this. Chop, stop, chop, stop, chop, stop, chop, stop. And I would actually make a bunch of them. I'm not going to draw a bunch of triangles. So then I could pick this up. I could pick this up and do this with it. I need you to, I didn't cut through, did I? Those go right up to the edge, so I can just open it up like this. Can you guys see that? Okay, maybe. So if I lay that down, it looks like this now. There. Yes? Roughly. I do all the same shit with this side, and I shove it in here. What shape have I made roughly?
A square.
Rectangle. How long is this side?
2
Pi r high.
Pi r. How long is this side? Radius. What's the area of that rectangle?
pi r times.
R times pi r. What's r times pi r? Pi r. There you go. Okay. So how do I find the area of a shape I don't know? I reorganize it into a shape I do know. Has anyone ever seen that before?
No.
That's really good to know. You should never accept shit on blind faith. If your teacher can't explain it, then you should say, well, then don't use it, man. If you can't explain it, then don't use it. Nah. You guys, maybe don't try that. But you should be able to say that. Okay. Does anybody feel any better or knowing this? I mean, it's just good to know where the hell it came from. We didn't just go, I like pi. And circles are square, and pi are square. No, get out of here. Okay. So the area is pi r. But don't we know that r is 60t? Isn't the radius of the circle getting bigger every second? So the area of the circle is getting bigger, yes? I need you with me. So if I take A, so this is A as a function of radius. So I need you to really see this going on. This is A of R, but R is R of T. Oh shit, okay, so what am I saying? The area as a function of radius is pi r. I left the square off. I love myself so much. Square. Area as a function of the radius is pi r squared. But the radius is a function of time, and it is specifically 60t. So how do I get area as a function of time? Shove it in. What is r of t?
60t.
And what's a of 60t? Pi times 60t squared. 3600 pi t squared. So now, I could say after 3 seconds, what's the area? Now I would do 3600 times pi times 3 squared, and that would be the area in square centimeters of the circle. If I wait another second, the area gets bigger, of course. Are you guys at all with me? No? What's up? Is everybody cool with the first thing? Radius is 60 centimeters per second. So 60 times t is how much the radius is. What's the area of the circle after 1 second? Well, the radius would be 60, correct? And then I could plug a 60 in and figure out the area. Well, what's the area of the circle at any time? Well, what's the radius at any time? 60t. And what's the area? Pi times radius squared. But what did we just say? The radius is 60t. So I just plug a 60t in, and I get a function, area as a function of time, directly. So do I have to know the radius to get the area of this circle? No, I just have to know how much time has gone by since I threw that stone in. Maybe? After 7 seconds, how big is this circle? What would you do? No, that would tell me the radius. I want to know the area. I would just plug 7 in for t down there. So the area as a function of time is this. I need you to see. I could do, okay, 7 seconds makes this 420, right? 420. And then if I take that and I plug it in here, that's a 2-step process. But now I'm saying, screw that shit. I know the radius is 60 times time. I plug that into the area function, and now I can just plug a freaking 7 in right there. So how do I determine after 2 seconds, what's the area? What would you do? Plug a 2 in for t. I don't need to know the radius because now I made my area directly related to time. This is a physical, real-life situation of shoving a function into another one. We actually do it all the damn time in all kinds of STEM classes. They're not going to say I'm going to show the function, and they're not going to say that. They're going to say something like, let's rewrite the area as a function of time. But how do they do it? They shove one function into the other. Maybe. Up here, what do I have to know to figure out the area for this equation? Radius. If you tell me the radius, I can get the area, correct? You with me? What do I have to know up here to know the radius? Time. So it should make sense. If somebody just gives me what time has gone by, I should be able to go directly to the area. And that's what this function does. Okay. Maybe. All right. So that's a little trippy. That's a real life example of compositions of functions. So that can get very trippy. I don't know if I'm going to make it. Man, there's so much to talk about. Let's do this. I'm going to shut up for a little bit because the first part of this handout is just composition of functions. Actually, the first 4 problems. So I'm going to shut up for a little bit. I want you guys to, let's start off by yourselves. Work on the first 4 problems. A, B, C, D. So just work on all right, guys, let's take a look. Whenever you have a problem that the question doesn't have x in it, don't shove an entire function. If this said f of 7, wouldn't that have been a nicer problem? Do you agree? If I would have just said f of 7, does everybody agree that would have been a nicer problem, right? And you're like, yeah, we know you're not that nice, Jeff, so. But what is g of 2? Could I figure out what g of 2 is? And then it's a number. And then I shove it into f, right? So what do we do with most algebraic computation stuff we have to do? We start on the inside. So if I only knew what g of 2 was, I would know what number to plug into f. So kind of do this in steps. You don't have to write everything at once. I'm going to take g of 2 by itself, and I'm going to figure out what the hell it is. So here's the g function. I'm going to take 2, and I'm going to shove it in here. So how do I do this? What's 1 minus 2? Negative 1, right? And what's the cube root of negative 1? What's the cube root of negative 1? Negative 1. And what's 1 plus negative 1? 0. So what is f of g of 2? It's f of 0. And what's f of 0? I just take a 0 and I shove it in to the f function, right? That would be 2 times 0 minus 1. What's 2 times 0 minus 1? Negative 1. I need this to make sense. Like g of 2 itself. That was only weird because there was a cube root, but otherwise it's just shove the number in, correct? The minute I know what number that is, that's what I'm shoving into f. So I take a little side trip and I just figure out what the hell is g of 2. If I just knew what that was. What's wrong with this math boy? Why didn't you just give me a number, damn it? But you have to, if you do the work, figure out what g of 2 is, that's the number. Now you take that number, you plug it into f. So what do I do first in part B? What do I do first here? Yes, if I only knew what number this was, I would know what to put into g. So I just take a second and I figure out what is f of negative 3? How do I do that? How do I do it?
Becomes negative.
Yes, I take that negative 3 and I shove it in here. Twice negative 3 is negative 6 minus 1. Now I know what I'm shoving into G. F of negative 3 is negative 7. This is 1 plus the cube root of 1 minus negative 7. Now here's where you really have to be nice to yourself. The more organized you are, the less you're going to make silly mistakes. Like I always get somebody who leaves off one of these negatives and things get really weird. This should be a nice problem. What's 1 minus negative 7? No. 8. What's minus a negative? Plus. So what's 1 plus 7? 8. Okay. So those mean 1 plus the cube root of 8. What's the cube root of 8? 2. What's 2 plus 1? Tree. Exactly. That's where trees came from, kids. A lot of people added 1 and 2. Okay. Do you notice how the idea of substitution just repeated substitution? This is put a negative 3 into F and then put whatever you get into G. And I could have put more shit on the outside of that and made everyone go crazy. Now what am I shoving in? Now I gotta use what? I gotta use the X. I don't have a number, correct? But what is F of X?
2x.
So now I know what I'm putting in where. I'm putting 2x minus 1 into G. And what is the G function? 1 plus the cube root of 1 minus stuff. And what's the stuff? So one big mistake I see is people forget the parentheses. I've got to subtract the entire f of x, not just part of it. So the negatives should distribute. Okay. Very exciting. So I appreciate everybody remaining calm. Okay. So this becomes 1 minus 2x plus 1 is 2 minus 2x. And that's basically all you can do. That's the great thing about not having a number being plugged in. You don't have to simplify anything. I mean, you can do simple stuff like what we did, but I can't go any further. What's the cube root of 2 minus 2x? I don't know. I'm gonna die. It's been good knowing everybody. So what's weird about that last problem? I say attempt not to die. Does that last problem look a little weird? I'll be right. Hopefully. What am I shoving into what? I'm shoving f into itself. Yes? What is f of x? So, and what is f? 2 times stuff minus 1. What does the f function do? It doubles stuff and then it takes 1 away. What is it doubling and taking 1 away from? 2x minus 1. So it doubles it and then it takes 1 away. What can I do to simplify this? 4x minus 2 minus 1 is? You get tired of waiting. It's minus 3. 4x minus 3. Okay. Does anyone see? We're doing more with functions on the sheet than we were before, but you guys see how it's all just substitution? It always comes back to substitution because that's all functions really mean. Function notation, I should say. Now to explain part E. It's going to take a little while. So we're going to get started now. As I try to stay alive. I don't know what's going on with me. By the way, last week I know I let us out early. I felt really weird. I had to go home and take a nap. And I'm alright. Getting old was awesome. Can somebody tell me, if I tell you I squared a number and I got 16, can you tell me exactly what number I squared? Nope.
4.
Hmm? I want to know exactly what number I squared. So, can you tell for sure, if I just say I squared a number and I got 16, can you tell me for sure what I squared? It could have been 4, or it could have been negative 4. You with me? So you can't tell. You don't know. So everybody's with me so far? What if I told you I cubed the number and I got negative 8? What number did I cube to get negative 8? Negative 2. Could it have been anything else? No. So I really want you to really pay attention to what just happened. If my function is x cubed, an input at negative 2 leads to an output at negative 8, correct? That's why, that's one example of why it's a function. Every input has only one output, yes? But more specifically, where did negative 8 come from? What input did arrive at negative 8 output? Negative 2, yes? So not only does every input have only one output, every output has only one input. Is that true for squares? The output is 16. Did it come from only one thing? No, it came from what? 4 or? Negative 4. You see what I'm saying? So, I really want you guys with me. To be a function, every input can have only one output. To be an invertible function, and all this means is, if I was a detective, and I'm working with a cube, and I'm like, I see there's a negative 8 on the ground. What did cube do to make a negative 8 cube negative 2? I can solve that mystery with me. If it's a square function I'm working with and there's a 16 laying on the ground, what that function do, I don't know, it's 4 or negative 4. I can't say for sure. You guys understand it? So that's how I kind of look at the idea of what's called invertible functions. If I say inverse to you, what better English word comes to mind when I say inverse? Anybody? If I want to take the inverse of something, I want to take the what of it? Reflection is good. The reverse is opposite's the best. The inverse of a function is somehow its opposite. Let me just stop for a minute. What does a function do? It takes inputs and gives me outputs. What would an inverse function do? Take the outputs and bring them back to the inputs. Could there be a function that could always take an output of a square and bring it back to its exact input? No. What did I square to get 16? Negative 4 or 4? I don't know. Okay. So, if, which way do I want to go with this? Yes, okay. So an inverse, all an inverse does is it takes the output back to the input. But if there were multiple inputs that went to the same output, it can't work. It doesn't work. If I'm trying to solve a murder case where what I know doesn't whittle down to one person, I can't solve the case yet. Right? But if the murder case is related to, like, you cube something and get negative 8, well, I cubed negative 2, I'm done. Negative 2 did it. Slap him in jail. Negative 2, I always knew he looked shady. Maybe. So what the shit does this mean? So what do you think the inverse, let me give you a simple example. What do you think the inverse of x plus 3 is? What does that function do? Why? The f of x equals x plus 3. What does that function do to any input?
Adds 3.
It adds 3 to it, yes? What would the inverse be?
Takes away.
So the symbol we use for the inverse is this. Now, on a fundamental level, does that make sense? I'm literally asking you, what is the opposite of adding? Now, obviously, that's a really simple example. When the function gets more complicated, it's nowhere near as easy. Yes? Okay. But let's try this out. Let me see if you guys see what I mean. When I input 7, into f, what do I get? 10. Crazy shit. This guy's job is to take an output and bring it back to the input. So if I take and I shove 10, its job is to undo what the function did. It is the opposite function. If an inverse exists, if you take the output of the function and plug it back in, it'll bring you back to what the input was. It'll solve that mystery. What do I get when I put a 10 into here? Put a 10 in, what do you get? Holy shit! Sorry. So 7 went to 10 because the function did something to 7 to make it become 10. The inverse function undid what was done and brought it back to 7. Okay, maybe. Maybe. Okay. If you let it be, that's really nice. Now things get a little trippy, but notice this. What point does my f function go through? 7, 10, yes? What point does my inverse function go through? 10, 7, yes? In fact, I could have made this any function. I could have made it so that this was 6 and this was 5, and then this would be 5 and this would be 6, yes? So what does it seem that an inverse function does? It takes the x's and the y's and it switches them. So watch this. This is so flippin' cool. I'm going to give you a little. I'm going to do this graphically first. So everybody copy this graph down. I know I have a graph on the paper, but I want you to do that on your own. There. This is very exciting. So let's say I've got -4, -2, -2, 0, 1, 2, and then 4, 3. So I've got this going on. It's not a very exciting one, Jeff. Too bad for me. So that is the function. Does every input have only one output? Yes. So it is a function. Does every output come from only one input? So like that output only comes from this input. In fact, how would I have to change this? Just a side note. I'd have to change this to be like this. Does this output here come from only one input? No. Do you see how it comes from 2 inputs? Do you see that? I need you to see that. This is so cool. You guys might not agree. A vertical line test tells me if it's a function. A horizontal line test tells me if it has an inverse. Can I do detective work? If I can square 2 different things and get 16, that means it has 2 outputs, 1 output for 2 different inputs. Then I can't work backwards. I can't go, where did 16 come from? 2 different things. I don't know. I can't solve the case yet. Shit. Maybe. I'll show you a whole nother reason why there's a horizontal line test for this after we talk about what this looks like. Can somebody tell me the points that this goes through? What points does f go through? What point is this? -4, -2. What else? -2, 0. What else? 1, 2. What else? 4, 3. So what points will f inverse go through? Yeah, all I do is I switch. That's it. Why? Because what's the inverse's job? To take the output back to the input. So I don't change any signs, I literally just switch them. And now I can plot those points. -2, -4, Jeff. Oh, there. Oh, there's stuff here. -2, -4. Where are we at? 0, -2. 2, 1. 3, 4. Chip-out, chip-out. Chip, become big. Chip-out. Now this is not my best example. It's a very simple example. It looks like a little bug maybe, yes? The function and its inverse. Do you see where there's a mirror? Does anyone see where there's a mirror? Yeah, there's a mirror like this, yes? There's a mirror right here. That line is the y equals x line. And it makes sense because how did we get this? We switched x and y. So it basically flipped over that line. Every inverse function, in order for a function to have an inverse, it's got to pass the horizontal line test. And then how do I graph the inverse? I just take all the points I see and I flip them. Do you guys understand how silly that is? Now, really quick little side note question. This won't be on the test or whatever. Has anyone ever heard of something called the Nazca lines in Peru? Okay. Anyone ever heard of the Nazca lines? You should look them up. Nazca. Used to be a Peruvian restaurant called the Nazca Cafe Grill, and they closed, and that made me sad because Peruvian food is good as shit. There are these lines down in Peru that they had put on the ground that you can only see them from way up high, so people had no idea how the shit they made them and how they knew what they made. So there was theories about maybe they had hot air balloon technology, and of course some people thought, well, obviously aliens were there, right? Who knows? It's the guy from the Discovery Channel with the hair. Okay, somebody knows what I'm talking about. I'm sorry. Just some of these functions, when we graph them, they remind me of the Nazca lines in Peru. If you've never seen them, you have no idea what I'm talking about. But look them up, Nazca. Maybe I'll show them to you next time. But for now, I think that's plenty. That's plenty. So next time we'll finish up inverse functions, and we'll get into linear functions next time, chapter 4. Oh, before I forget, let's have a quiz. On, let's do 3132, I think. Yes, 3132 on Thursday. Is everybody with me? Second quiz, 3132 Thursday. You want more grades if you didn't know. So you're welcome. I'll see y'all tomorrow.